মাইক্রোসফট বিংটা নাকি 4.0 দেয় ফ্রিতে।
Maybe never used
বাট
actually.
বিংটা অতটা ভালো না। বিংটা দেয় তো, বাট ইটস নট অ্যাজ গুড অ্যাজ দ্যাট চ্যাট জিপিটি।
But I heard the news that OpenAI may go bankrupt soon. Nah, API hai. Yes, if you are opening an account, then OpenAI এর API টা কি তুমি বানাতে পারো ফ্রিতে। You can create, you can utilize the OpenAI APIs for free. The Chat GPT 3.5 turbo version can be utilized. Okay.
এটা ডেলিটা দেবে ইমেজ জেনারেটর?
দেখছি একবার দেখছি ড্যালিটা এখন আমি ফিক্স শিওর না whether Dali is getting free or not, but I need to just see that a bit. কাল পরশুর মধ্যে বলতে পারবো এটা। In the next class I can tell that. So what is it? Basically the question is they have given a matrix. They have given a matrix and let's say you are having some data like this one. Everywhere is one, but the middle one is zero. At which row it is? It is in row number 1, right? So convert all the elements of row 1 to 0. Similarly, convert all the elements of row of column 1 to 0. So finally, my matrix is gonna look like how much? Finally, my matrix is gonna look like 0, 0, 0, 0, 0, 1, 1, 1. All the column and row elements of 0 have successfully been converted to zeros. Okay. एक और एग्जांपल देख लो, ये तो आसान सा प्रॉब्लम है एक्चुअली, पर बेसिक लूप वाला ये तो हो जाना चाहिए भाई. So what is the thing is that, yeah, similarly here, you are having a 0 here. So all the row elements of this 0 will be converted to 0. All the column elements of this 0 will be converted to 0. Similarly, all the row elements of this 0 will be, they are already 0. On account of the first 0, all the elements corresponding to this row as well, or this 0 as well, has been already converted to 0. Now only the column elements of this 0 needs to be converted to 0. So finally, all the elements of the first row, first column, last column are successfully converted to 0. ये simple loops का problem है, कुछ नहीं करना है, ठीक है? In place means whatever input you have been given in terms of matrix, you have to make the changes there only. Correct? Nowhere else you are allowed to do that. Okay, बोलो इस क्वेश्चन में कोई डाउट है? आसान सा क्वेश्चन है, एक बार ट्राई करना, अगर ना हो तो फिर नेक्स्ट डे आमिर एक बार दिखा देना, ठीक है? हो जाना चाहिए, होपफुली हो जाना चाहिए ये वाला, ठीक है? और डाउट है इस क्वेश्चन में? सेट मैट्रिक्स टू 0?
नहीं सर।
ये if an element is 0, set the entire row and columns to zeros, ठीक है? That's what we are asking. Fine, तो चलो we can move on, right? Previous day कौन से पॉइंट तक हुआ था अपना? आज का कल का वीडियो मिल गया आप लोगों को? कल का वीडियो
ওটা আপলোড হয়েছে কি?
ওকে সরি, আই থিংক আমি আপডেট করিনি তোমাদের
কার্ডান্স অ্যালগরিদম।
হ্যাঁ, কার্ডেন্স অ্যালগরিদম।
Okay, fine. So, can we move on for today? Can we move on? Previous day, linear search, all of you are clear with. Am I correct? Linear search का topic आपको clear है? ठीक है, चलो, let's move on. Let's switch to the main topic today, that is binary search. Tell me that what do you mean by binary search? Anyone? So when do you apply binary search? When your entire array is sorted. Getting my point? When your entire array is sorted. 1, 5, 2, sorry, not like this. 1, 5, 6, 9, 10, let's say. And I say that you are searching for, let's say, okay, let me draw a bigger array in that case. Let me say your 2, 3, 4, 5, 9, 10, 11, 12. Let me say you are searching for 11, correct? Then, okay, one way is search it linearly from the starting to the end. Search it linearly. Then I can say whenever my index variable goes to the second last value, then here I am able to find my element. I stop my searching at this point. Am I correct? This is how you search it linearly. Okay, let's see how can we optimize. We know that our array is sorted. The array is sorted in increasing order or decreasing order, correct? What can we do now? Okay, so I say my entire searching zone is from the starting to the end index. Initially, can I say my answer can be present from start index to the end index, anywhere in between them? Can I say that? Tell me that. Initially, before we have started on the searching, in between to start and end, anywhere my element can be present. Correct? So let me write it. That initially my start is at, okay, initially my start is at index 0, end is at index 7. Let me do one thing. Let me point my mid to the mid element. Let me have a mid pointer and that points to the mid element of the array. Got my point? Mid pointer, mid element pe point kar raha hai. Correct? Tell me one thing. So how do I calculate the mid? I can just say it is equal to start plus end divided by 2. So this is equal to third. Third index, my mid pointer is pointing to the third index element. Now tell me for one thing. If the mid element is smaller than 11, whatever is the mid element, that is smaller than the required element k, then what is the inference that you can draw from here? Bolo. क्या ऑब्जर्वेशन आपको मिल रहा है? ओवरऑल ऑब्जर्वेशन आपको क्या मिल रहा है? मिड एलिमेंट क्या है? स्मॉलर देन के है, रिक्वायर्ड एलिमेंट. देन व्हाट यू आर गोना डू? See, array is sorted, right? Can I say whatever elements I am having in between start to mid, all are smaller than k? Can I say that? From your start to the mid, since the array is sorted in increasing order, start से लेके mid तक इस पूरे रेंज में ग्रेटेस्ट एलिमेंट कौन सा है? कोई बता पाएगा? From start to the mid, which element is the greatest one? Can anyone tell? This element, this particular index is having the greatest element, that is 5. All the elements towards the left of mid are smaller than that. Can I say that? Can I say or not? Since the array is sorted, right? So all the elements towards the left of mid will be smaller than or equal to mid. So if this mid is smaller than, the greatest element of the range is smaller than k, all the elements towards the left of mid will also be smaller than k. Can I say that? Can I say that? Array is sorted. So from start to the mid, inside this range, all the elements are what? Mid element is smaller than k. So since towards the left of mid, all elements are smaller. So if mid is going smaller than k, all the elements from start to mid will be lesser than k. Correct? That's an inference we can draw. So what we should do now? अब क्या करना चाहिए? Tell me what we should do now. My mid element is smaller than k. Now what we should do? Can I say now keep on searching? Now shift your start to mid plus 1 and now search from start to end. Search in between new start to end. Okay, got my point? Since this entire region is useless for me now. Why? Because all the elements here are smaller than the required element. So I can go towards the right of mid and keep on searching my required element k. So I shifted my start to mid plus 1. Correct? Okay. Let me, my new elements are 9, 10, 11, 12. Start is here, end is here. What is the start index? Start is 4, end is at 7. Where will be the mid line? Can you tell me? Mid index will be pointing where? Can you tell me? At index 5, right? So your mid points here. Now next what will happen? Can you tell me? Kya hoga? When my mid element is pointing to 10, what will happen? What is the new observation I can have? Again, see, the mid element is smaller than k. Can I say that? Mid element is again smaller than k. So again, from start to the entire mid, every element is smaller than k. Now you again exclude this region, shift your start to mid plus 1. Shift your start to mid plus 1. Got my point? Shift your start to mid plus 1. So I can say my new region is having just 2 elements to be searched for. Where my start is pointing to 11, end is pointing to 12. I will now say, okay, my start is at where? Start is at index 6, end is at index 7. My mid will be also pointing here. Mid will also be pointing here. 6 plus 7 divided by 2, integer division. Okay, so this is 6. Can I say right now, wherever my mid is pointing, that is containing the element k. Can I say that? So now print the value of the mid wherever you have found the element and stop searching further. Got the point? How binary search is working? You are exploiting the fact that if my mid element is smaller than k, then from start to the mid, all elements are smaller than k for sure. So I am ditching this entire, I am just completely leaving this entire leftover region, whatever right whatever right half of n by 2 elements are there, I am going there for the further searchings. Let's take another example. एक और example देखो. So let's say 2, 3, 4, 5, 9, 11, 12, 13. Now let's say you are searching for 2, k equal to 2. Correct? Start is here, end is here. Okay, again we are having start at 0, end at index 7, right? Yeah. Okay, so my midpoints here. Now what you can say? Now what inference you can draw? Mid element is having element 5. Can I say? Mid element is having element 5. It is what greater than the required element k. Now what should happen as per you people? क्या होना चाहिए अब बोलो? अब mid element greater than required k है तो क्या होगा? क्या कह सकता हूँ एक बात? Tell me. Since mid element from mid to the end, which is the smallest element? From mid to the end inside this region, which is the smallest element? Can anyone tell me that? Mid is having the smallest element. As you go towards the right, your element increases further. So if the smallest element of the region is greater than k, can I say all the elements of from mid to end will be greater than k for sure? बोल सकते हैं कि नहीं बोल सकते? बोल सकते हैं कि नहीं बोल सकते? बोलो. So what we are to say here? What we are to say? We will say end will be now shifted to mid minus 1. We know that at mid element is not present. It is greater. So I can say my end shifts to mid minus 1. What is my leftover region? Leftover region क्या बनेगा बोलो? 2, 3, 4. Start is at here, end is at here. Now my mid points here. As per the start and end values, mid will be pointing here. Next, what will happen? Next, this particular 3 is again, mid element is again greater than the required k. Am I correct? So again, from mid to the end, all elements are greater than k for sure. So again, I can shift my end to mid minus 1. Now you are left with just a single element to be searched for. अगर यहाँ पे element ना मिला, मतलब element present नहीं है. Got my point? This is the last point of searching where my start and end both coincide at a single element. Got my point? Got my point? This is the last point of searching where my start and end are both are coinciding to the same element and my mid also points here. If start is at index 0, end is also at index 0, mid will also be at index 0 only. Start plus end by 2. Got my point? Okay. So at the last mid index, I am able to find that, okay, this wherever my mid index is pointing, that at that index, the required element k is present. So you print the element, you stop the searching further. Okay. See another example where suppose my element is not at all present. So what is the, see for one thing, observe for one thing, till the time searching was possible, at least till the last point, my start index was always lesser than or equal to end. Start marks the starting index of the searching region, end marks the last index of your searching region. Okay. From start, in between start index to the end index, you can search. It is not possible that start may become greater than end and you are searching them. Start should always be lesser than equal to end for a valid searching region. Correct? So that from start to end, I can keep on searching. Whenever my start is going greater than end at any point, if it becomes, it marks that your searching region has extended. No more elements are there present here. अगर आपका start index greater than end हो जाए, मतलब आपकी पूरी searching region खत्म हो गई. अब further searching हो नहीं सकती. You have to stop the searching. So let's take an example where there are no required elements are present. Let's say 1, 2, 3, 4, 5, 6. I'm searching for 7, let's say, or you can just have another kind of sort. 1, 2, 4, 6, 7. Let's say I'm searching for 5. So my start initially points here, my end initially points here. As per the rules of binary search, I have to keep on searching. Okay. First element will be this. First element will be, mid element will be this 3. Mid points here. What's gonna happen now? बोलो क्या होगा? बोलो कोई क्या होने वाला है अभी? मिड एलिमेंट 3 पे पॉइंट करता है तो मुझे क्या करना पड़ेगा? As per the rules of binary search, I should go. Mid element 3 is smaller than 5. Can I say required element? So as per binary search, I have to shift my start to mid plus 1. This entire region won't be having the required 5 for sure. I need to shift my start to mid plus 1. Leftover elements are 4, 6, 7. Start is here, end is here, right? Again, my midpoints here. Again, my midpoints here. Again, my midpoints here. Let me write here from now onwards. Start value is at index 3, end is at index 5. Now, midpoints to 4. Midpoints to 4. Mid element is again greater than the required, is now greater than the required element 5. So I should say from mid to end, all elements are greater than 5 for sure. I cannot find it here. Fine. So I'm left over with just I should shift my end to start. Wherever my start is pointing, I have to shift my end now there, because I know from mid to end, none of the elements is equal to that of your required k, 5. Fine. Now I have to shift my start also points to this 4, end also shifted to this 4. Mid also, this is the last point of searching, last point of searching. Now I have to say start is at index, where is it? 3. End is also at index 3. Mid also points to index 3 only. Now what will happen? Can anyone tell? What will happen? Whatever is the required element you are having, 4, it is smaller than 5. Then what should I do? What should I do? I should shift as per the rules of binary search towards the right of my 4. I can have an element. Am I correct? If 5 exists, it should exist towards the right of 4. So I should shift my start to mid plus 1. That is at index 4. Now you are able to observe that when the last element also fails to search for the required element k, my region is finishing. No more elements are present. And what is marking that? The marker of that is your start index has gone greater than end. But for a valid region, I know start index should always be lesser than equal to end. So whenever my start becomes greater than end, my searching should stop here. And whenever this happens, I should say no element k is present inside the array. What is the marker of that? Your start has become greater than end. Got my point? How binary search is working. Got my point, all of you? Got my point? Tell me that. Any doubt? Should I repeat something? Repetition की जरूरत है तो बोलो. Should I repeat something? Can we move on for the coding part? Coding part करें? बोलो. So let's go for the coding part here and let's see how binary search works. ये क्या है? चलो ठीक है. No, you cannot apply binary search on an unsorted array. Correct? One case can be there, what we are gonna see at a later part, but you cannot on any random unsorted array, binary search can never be applied. Binary search is working on the principle that if the array is sorted, based upon the value of the mid, I have to choose whether the elements are present in left half or right half. That's the thing. What is the main criteria for that? If suppose my mid element is smaller than k, then all the elements from start to the mid, since the array is sorted, all the elements from start to mid will be smaller than k. So the element has to lie into the righter region. That's how you keep on dividing the regions into halves and keep on searching in the required half wherever there is a probability that kth element is present. Fine. That's the thing. So on any random array, linear search can be applied, but not binary search. Okay. So first thing is, let me see how can we apply binary search. So let me say that my array is having elements like this: 3, 4, 3, 5, 7, 8, 9, then let's say 10, and then let's say 12. This is my overall array. Then what should I do? Can you tell me what should I do? Value of n is equal to, let's say 1, 2, 3, 4, 5, 6, 7, 7, right? Okay, so I should start my searching from index 0. I should end my searching at index n minus 1. This is the initial zone of searching. Correct. Next, what should happen? What is the last point? Till the time my start is lesser than equal to end, I can keep on searching for my results, right? Let me keep another variable. At what index there is a probability, at what index my element is present. By default, let that be -1. That I haven't found where my element is there. I don't know. So by default, let that be -1. Even if I am unable to find the element, I can just say that my index value remains to be -1. So this -1 is a marker that element is not found in the array as well. Okay, how that's gonna be, we are gonna see that. So see what's gonna happen. int mid is there. अब बोलो क्या करना है? What is the thing? If suppose array of mid is having the required element k, so I should say let the k element we are searching for, let that be 2. Okay, of our array, let the element be 2. Okay, not 2, let's say it's 10 by firstly. If the array of mid is equal to k, it has we at the mid index I've got my required element k, then what should we do? Tell me. I will change my index value to mid. At this particular index my mid element is present, and I will break the loop from here. Else if my array of mid is greater than k, then what you should say? It's greater than k, then from mid to end all the elements are greater than k, so I should say end, shift your end to mid -1. Else there is just a single condition. What is that? Beyond this, just a single condition, array of mid is smaller than k, so your start should go to mid +1. That's it. At the end you just print where at whatever index your element is present, you print that. That's all, nothing else, right? Try running. So at 5th index, my required element 10 is present. Is it coming good? At 5th index, it is coming. Yeah, it's good, I guess. Change it to 3, let's say. At index 0, the result should be there. Okay. So yeah, at index 0, my required element 3 is present. What else should be there? Tell me. Let me say for a non-existent element, let that be 1. 1 is not present inside the array. So our answer should be -1. Okay. Answer should be -1. So at -1, that means element is not at all present. Is it clear how the coding part is working? Tell me that. All of you. How the code we have written, is it clear to all of you? Should I repeat something, or you are having any doubts in any of the part? Tell me. कोई doubt है किसी को तो बोलो. Your loop will be running till the time start index is lesser than equal to the end index. Till the time, keep on calculating the mid, and based upon the value of the mid, either break the loop or choose the left half or right half. That's what you are required to do. ठीक है? कोई doubt है तो बोलो. कोई doubt है? कैसे बाइनरी सर्च काम करता है बोलो. कोई doubt है? I'm giving the code on chat. TSA group. हो जाएगा. बाइनरी सर्च किसी ने भी दिया, कर लोगे? बाइनरी सर्च किसी ने भी कोड करने को दिया, कर लोगे आप लोग? कर लोगे या नहीं? प्रैक्टिस करना एक बार जाके. हाँ, बहुत इंपॉर्टेंट टॉपिक है. अब मुझे बताओ कॉम्प्लेक्सिटी कितनी आएगी इसकी? कॉम्प्लेक्सिटी कितनी आएगी बोलो? So I said that what in the worst case, see what is happening. Best case of binary search, what is that? Can anyone give me the answer? Best case of binary search, can I say best case is whenever your required element is present in the mid. In the middle in the middle index of the array, your required element k is present. So in just first search, I would be able to locate my required element. So in just big O of 1 complexity, I calculated for the best case. What is the worst case now? What is the worst case? Worst case scenario will be first I am searching on an array of n elements. Then based upon the value of the mid here, I will choose my n by second half. Then among this n by 2, I will further have a division of n by 4. n by 2 के half से इस half के mid पे भी नहीं मिला. First पूरे array के mid element में भी नहीं मिला. Required आप किसी भी half, left half या right half में गए, वहां के mid में भी नहीं मिला. फिर आप इसके किसी based upon the value of n by 2 जिस भी half में थे, उसके किसी एक half में गए, वहां पे भी नहीं मिला. At the end, I kept on dividing by 2. I reached the last element of my region to be searched for. That is, I am left over just with a single element inside my overall search region. ठीक है? So how many searches we did? At a region of n elements, I did a searching. At a region of n by 2 elements, I did a searching. Inside a region of n by 4 elements, I did a search. On the last element of the zone, I did a searching. So how many searches effectively we have done? Can anyone tell me? Effectively, how many searches? No, it's not 10. Wrong at all. Exactly wrong. Firstly, I am searching inside a region of n divided by, for any general value of n can be hugely large, okay? For any general value of n, first you are searching inside a region of n by 2 to the power 0, n divided by 1 basically. Then you are searching inside a region of n divided by 2 to the power 1. Then you are searching inside a region of n divided by 2 square. Then you are searching for n divided by 2 cube. And at the end, when some largest power of possible 2 divided the n, it turned out to be 1. When your entire region shrink to just a single element, that is, I divided with some power of x and it just reduced to, my entire region reduced to 1. This is the last region where I did my searching. So how many overall searches we did? Count the number of powers of 2. For each power of 2, we have a search corresponding. Am I correct? करेक्ट बोल रहा हूँ कि गलत बोल रहा हूँ? हर एक पावर ऑफ 2 के लिए एक एक सर्चिंग है. इस रीजन में एक सर्च किया, इस रीजन में एक सर्च किया, यहाँ पे एक, यहाँ पे एक. एट द एंड 2 to the power x के लिए लास्ट सर्च कर रहे हैं. तब जाके एलिमेंट यहाँ मिला तो मिला, नहीं तो सीधा सीधा बोल दिया कि एलिमेंट प्रेजेंट ही नहीं है अरे में. बोलो कितनी सर्चिंग्स की ओवरऑल? फॉर ए रीजन विच इज गेटिंग डिवाइडेड बाय 2 to the power 0, then 2 to the power 1, then 2 square, then it is going till 2 to the power x. Overall, I am having x plus 1 searches. Am I correct? Roughly x ही मान लो. X roughly you can assume it's x. Plus 1 does not matter much. So what is this value of x? What is this value of x? Can I say, I can just write the relation, right? N divided by 2 to the power x equals to 1. What is this value of x? कोई बोलो? If I am coming up with this, that at the end when I divide n with the value of 2 to the power x, it is reducing to 1. क्या आएगी वैल्यू? चलो रेसिप्रोकल लेते हैं, ठीक है, इस रिलेशन का. 2 to the power x divided by n is equal to 1. अब आप उधर पे लेके चले जाओ. 2 to the power x equals to n now. Next, take log 2 on both sides, log base 2 both sides. So log base 2 2 to the power x equal to log base 2 n. ठीक, x मल्टीप्लीकेशन x पावर में है, मल्टीप्लीकेशन फॉर्म में आ जाएगा. ओवरऑल इट इज x इंटू लॉग base 2 value 2 equal to log 2n, correct? So overall this term is 1. Why? Log base a value a is always equal to 1 for valid values of a, okay? So this term reduces to 1. Overall x is reducing for us to log base 2n, okay, or log n. So overall how many searches we did here? Log n plus 1. What's my complexity? Turn into big O. 1 is constant neglect. Overall, the complexity is big O of log n. How this is beneficial? Suppose that you are having a sorted array. You are having a sorted array of length 10 to the power 6. Got my point? In the worst case of if in the worst case you are, suppose that array is sorted by default. In the worst case, I would be able to search inside this array in 10 after having 10 to the power exact searches, right? After doing exact 10 to the power 6 searches inside the array, I got my result, let's say. What if the array is sorted and I applied binary search? How many searchings you will be doing? Effective number of searches will be, in the worst case, log base 2 10 to the power 6. 6 comes into multiplication format, right? This 6 will be coming to the multiplication format. So 6 into log base 2 10, correct? What is this term equal to? It's roughly 3.5 approx, you can say. So initially with linear search, I was requiring in the worst case 10 to the power 6 searches. With the help of binary search, if the array is sorted, right, I will be requiring 6 into 3.5 number of searches. Effectively, it's equal to 21. So see the drastic change. From this, from a huge power of 10 to just 21 searches, I found my result. Got my point? That's how your search space reduction helps me. So that's how your performance is very good with the help of binary search in terms of your sorted arrays. Okay? कोई doubt है? कोई doubt है? कोई doubt है तो बोलो. बाइनरी सर्च के बेसिक्स में कोई डाउट है अभी तक? कोई डाउट है किसी को? एनीवन? हो जाएगा, इतना दूर आप लोग कर लोगे, बोलो. अब कोई भी बाइनरी सर्च पूछ ले, बोल दोगे, कर लोगे? कुछ तो बोलो यार, कुछ रिपीटेशन की जरूरत है. Any repetition is required? At any point, any repetition is required. All of you, Aniket? Okay, move on. Chalo, let's have a first question of binary search. You are given an array that is sorted but may have duplicates. Okay, I give you the value of k equal to, let's say, 3. Find the first occurrence of 3 into your array. Can you do that? Can you try this? Find the first occurrence of k into your given array. Can you try this? If I am saying first occurrence of 3, for corresponding to 3, it is in index 4, I guess. Yeah. So fourth index you have to print. Can you try this? हो जाएगा? Try करो तो कैसे करोगे? All of you try that. Please, all of you try this question. ओके बोलो कैसे निकालेंगे फर्स्ट ऑकरेंस हाउ वुड यू फाइंड इट एनीवन 1 2 2 3 3 3 3 and 4 4 inside this region from index 0 to index which element no elements to index 8 my elements my first occurrence of 2 can be present, right? So what should I do? Let me keep at what index initially it's present. By default it's -1. What if your 3 is not present inside your array at all? Also a possibility, correct? 3 present ना है मतलब कोई first occurrence है ही नहीं तो -1 in such cases. So my start is at index 0, end is at index 8. Mid value कहाँ पे point करेगी? Index 4 पे, यहाँ पे, right? अच्छा ये तो पहले ही मिल गया यार, तो फायदा ही क्या हुआ? अच्छा चलो k की वैल्यू को चेंज करो. K, let the value of k to be 2, correct? Now let me for k equal to 2, the first occurrence should be at index 1, correct? Achha. So my mid is pointing here right now at the value 3. 3 is greater than 2. So if 2 is occurring into my array, it has to be towards the left of mid element. अगर 2 occur करता है array में तो mid के towards the left ही करेगा. Am I correct? अगर 2 को occur करना है तो 3, current element 3 है उसके left में ही करेगा. So I should shift my end to mid -1. Now my end points here, start points here. So 1 and then अब तो मिल ही गया यार, अभी क्या ही रहेगा और 1 2 2 2 and let's say my start is here and end is here right now. Okay, fine. Mid points here now. Can I say into my current sorted region mid points here? At this mid, the required kth element is present. required kth element is present inside the mid, right? So I can say, okay, this is the possible answer for us. Let me update the mid index to the index value, that is 1. Now there is yet another chance. Wherever आपका mid जहाँ पे भी है ना, उसके लेफ्ट में और occurrences of 2 हो सकता है, चांसेस है. तो मैं बोलता हूँ ठीक है, एक काम करो, एंड को आप mid -1 पे शिफ्ट कर लो. एक आंसर तो एक single occurrence of 2 I have got. Even if no other occurrence is there, this particular occurrence can serve as my answer. Its index can serve as my answer. This is the first and last occurrence. If there are more occurrences, correct, of 2, chances are there, if towards the left of 2, more occurrences are there, I can have the first occurrence towards the lefter index of my current answer. So I'm gonna say shift your end to mid -1. Even if I found an occurrence, shift your end to mid -1. So what it is, I'm left with just a single element. Start is here, end is here, correct? Mid will also be here, mid will also be here. So at this mid element 1 is there. Mid element में क्या है? Required element 1 है. That is lesser than 2. So अगर 2 को occur करना है अब, तो start को mid +1 पे लेके जाना पड़ेगा. Start was at index 0, end was at also index 0. Now it changed to 1. So this is the scenario that all the elements inside your searching zone has exhausted. कुछ बचा नहीं है. So I should stop my searching here. Whatever आपके index में final value रहा, this is the value where your first occurrence of 2 is lying. Okay, let's try this with the same example. Let's try with the example of 4. 1, 222, 333, 333, then 4, 4, correct? 4 का आपको first occurrence निकालना है, मान लो. Start आपकी 0th index पे, 8th index पे end है. Mid कहाँ पे point करेगा? 3 पे, correct? Mid will be pointing to this 3. अब क्या करना है? बोलो. What should we do? What should we do? अब क्या करना है? चलो मान लो कि आपके पास एक और 4 है. Let's say that there are overall 10 elements. So my mid will be pointing. Start is at index 0. End कहाँ पे? Index 9 पे. Mid कहाँ पे रहेगा? Index 4 पे ही रहेगा. ठीक है? Index 4 पे mid रहेगा. So 3 है. Right now my element is at 3. Am I correct? Right now my index is at 3. अच्छा चलो मैं एक और change करता हूँ array में. Let after this 3, let there be 4 4s for us. ठीक है? 4 4 है. तो अब आप क्या करोगे? बोलो. मिड एलिमेंट पे 3 रखा हुआ है. 3 इज स्मॉलर देन 4. तो मुझे अब क्या करना चाहिए? मुझे अब क्या करना चाहिए वो बोलो. So if suppose 4, if 4 has to occur, if the kth element has to occur into the array, it has to be towards the right of mid. It has to be towards the right of mid. Mid element is smaller than 4. If 4 is occurring, 4 को अगर array में occur करना है तो right of 4 पे occur करेगा. Correct? So now I am gonna search 3 and inside the region of 4 4s. So I am gonna say start is here. I am gonna say end is here. Correct? Okay. Start is at index what? At what index start is there? At index 5 and at index 9. Correct? So at index 7, my mid will be pointing for this region. Am I correct? Mid will be pointing at to this 4. So I know that one occurrence of 4 I have got at the mid index. So let me update my index which is initially -1 to index 7. Index 7 में एक 4 है. कोई और occurrence ना भी हुआ तो यही first occurrence के हिसाब से काम कर सकता है. अच्छा, पर एक और chances है ना, towards the left of 4 और भी 4 occur कर सकते हैं. Towards the left of 4 more 4s can occur. So अगर first occurrence मुझे choose करना है, first occurrence अगर मुझे select करना है, calculate करना है, तो towards the left of my current mid जाना होगा. Then what I need to say, my current region is reducing to 2 elements. Start is here, end is here. फिर क्या करेंगे बोलो? Mid will be pointing here at this element. Here 3 is lying, which is again lesser than 4. अगर further 4 के और occurrence occur करने हैं तो मुझे अपने searching region को towards the right of current mid लेके जाना है. Correct? Towards the right of current mid लेके जाना है. So only one element remains, that is 4 itself. Start also points here, end also points here, mid also points here, mid also points here. So at the mid element there is 4, I guess. Am I correct? You are having 4. So one occurrence of mid is equal to right now for us equal to that of 6, I guess, right? Yeah, it is 6. Mid is equal to 6. So what should I say? 0 1 2 3 4 5 6. Yeah, it's 6. So अब क्या करना पड़ेगा बोलो? At the mid index I know, I have the required element k, and where at the mid value, whatever is the current index value, it's lesser than that of my previous index. That means this particular occurrence can be counted as the first occurrence rather than that of its previous one. First occurrence is what? If any index at index idx1, your element A is occurring, and at some other index idx2, which is which is greater than that of your previous occurrence. At both these indices, A is occurring. First occurrence will be counted at the lesser index one, right? At that, for the first time inside any of the indices, at the least index value, the element A is occurring. So this particular is serving as the least value so far, such that at this particular index, the required K has occurred. So I'm going to say update the index value with your current mid value, that is 6. Update it. So finally, I say after this, my start will be, now after this, what will be happening? Start is at index 6, end is at index 6. As per the current analogy, I should say for one thing that towards the left of my current mid, more force can occur as per my current analogy. Now, what's going to happen at this point? My end will be shifting to mid -1, that is 5. So again, your start becomes greater than end. At this point, I should stop searching. Effectively, it means that your entire search region has exhausted. So at the end, whatever your index value is storing, that is 6, that's the first occurrence of required element 4. अगर index value -1 रह जाता, मतलब कि कोई element as per the kth value is not occurring inside the array at all. Okay, got the point? How to calculate the first occurrence? Tell me that. फर्स्ट ऑकरेंस कैलकुलेट करने का पॉइंट मिल गया आपको, वो बोलो ऑल ऑफ यू. फर्स्ट ऑकरेंस कैसे कैलकुलेट करते हैं? पॉइंट मिला, समझ आया? ऑल ऑफ यू, व्हाट शुड आई अज्यूम? शुड आई रिपीट समथिंग? रिपीट करना है तो बोलो. एंड नाउ हाउ द कोड विल बी चेंजिंग. कोड चेंज कैसे होगा, बोलो कोई. Can anyone tell me how the code should change? Only one thing. What is that? Whenever I found this current mid index is having the required element K, assign the index with the value of the mid and then keep on searching towards the left. You still say that index equal to mid and then your end goes to mid -1. That's the thing. You have to keep on searching till the time entire region has got exhausted. There is no break point because towards the left of my mid, further occurrence of K can occur. Even I am finding it at one of the places, at one of the indices. Else, the remaining conditions are same. Your current mid is greater than the required K. So if K has to occur, it has to occur towards the left of K. So end equal to mid -1. Else, suppose array of mid is lesser than K. So if the element K has to occur, it has to occur towards the right of my mid. So start equal to mid +1. Everything remaining is same. Okay. You may try this. Let me change the array a little bit. Let that be equal to 3, 3, 3, 3. Correct? Then 4 and 4, let's say. And let's say it is 10. Okay, just a moment. Fine. So let's say I am finding for the first occurrence of 3. It should be at index 0. Am I correct? 1, 2, 3, 4. Yeah. So let us say where the result is coming or not. Let me say that. Let me see. So at index 0, first occurrence of 3 is coming up. Let's say for value 4, where the first occurrence is, it should be at index 4 only. Okay. At index 4 only, the first occurrence of element 4 should lie. Yeah, it's coming good. Try for any non-existent element. Suppose 5 not occurring, it should be at -1. The first occurrence should be at -1. Done. समझ आया सबको? फर्स्ट ऑकरेंस कोड कैसे करते हैं बोलो. सिंपल सा चेंज है. फर्स्ट ऑकरेंस सिंपल सा चेंज है. समझ आया सबको? वो बोलो ऑल ऑफ यू. समझ आया या नहीं? बोलिए. अच्छा. इफ आई नाउ से काउंट फॉर द लास्ट ऑकरेंस, कैन यू ट्राई? बोलो तो कैसे करेंगे? 1, 222, 333, okay, not 333, let's say 3 and then let's say 4, 4, 4, 4. Count for the last occurrence of 4. कैसे करोगे बोलो. काउंट फॉर द लास्ट ऑकरेंस ऑफ 4. क्या करना है, पहले स्टार्ट यहाँ पे है, एंड यहाँ पे है, ठीक है. जस्ट मिड एलिमेंट इज एट दिस एलिमेंट, एम आई करेक्ट? मिड इज हियर. फिर क्या करोगे? ओके, आई डोंट थिंक सो मिड विल बी हियर. मिड विल बी एट दिस 3 आई गेस. या मिड यहाँ पे होगा, ठीक है. मिड विल बी हियर. देन व्हाट विल हैपन, टेल मी. मिड विल बी हियर. एलिमेंट 3 इज लेसर देन रिक्वायर्ड एलिमेंट 4. टुवर्ड्स द राइट सर्चिंग करनी पड़ेगी. टुवर्ड्स द राइट सर्चिंग करनी पड़ेगी. अगर 4 ऑकर करता है तो 3 के राइट में ही करता होगा, ठीक है. आई एम लेफ्ट विथ 4 4s राइट, ठीक है. So again, start comes here, end comes here. Am I correct? So mid will be at this position. Mid will be at this position. Required elements. By default, index is -1. Required mid is having the required element k. At this, my current mid is having the required element k. So I should say, what is the index value by the 0, 1, 2, 3, 4, 5. At index 6, I found the occurrence of 4, right? I found the occurrence 4 at index 6. So update. Even if no occurrences are there further, this element can serve as the first and last occurrence. Okay, fine. But if I am to find the last occurrence, I have to say keep on searching towards the right. If you are finding for the last occurrence as compared to your current mid, the element can lie. Even if I am having at my current mid the required element, towards the right of it, more occurrences can be there. So keep on searching towards the right. So shift your start to mid +1. Correct? So I'm left with 2 4s right now. One is start here, one is end here. Mid also points here. Mid also points here. क्या करोगे अब बोलो? अब क्या करना है? At this mid index again, my required element k is present. I am right now, the mid value is what? Right now, whatever is the mid value, that is having index 7. So this index 7 occurrence is a latter occurrence as compared to 6. So I should be taking into account that this element can serve as this element as compared to the previous occurrences. This element can serve as the last occurrence, even if no further occurrences are there. So I will keep the latest index with me. So I'm going to update that with 7. And I'm going to say, okay, I got an answer here. Towards the right, further 4s can be there. So shift your start to mid +1. So I can say 4 is here, the last 4 start is also here, end is also here, mid is also here. The mid index is equal to that of 8, and I can say at this particular index again a 4 is occurring. Am I correct? Again a 4 is occurring. तो अब क्या करना पड़ेगा बोलो? This is the latest occurrence I got of 4. Even if no further 4s are there, this can serve as me. This can serve for me as the last occurrence. So I say update your index with the current mid value, that is 8. And towards the right of my current 4, further indices may lie. So my current start is at index 8. End is also at index 8. I am going to say search, keep on searching towards the end of your array, towards the right of your current mid, sorry. So shift your start to mid +1, that is 9. At this particular moment, start goes greater than end, and all the entire search region has exhausted. Entire search region has exhausted, correct? So I should stop my searching here. My loop will terminate by default. So at the end, inside in the index 8th value, that is the 8th index value is lying wherever my last occurrence of 4 is residing. So my index has that value. So it's simple that right now, just one change I require to do. What is that? For the last occurrence, I have to keep searching. Even if I got my required element, I have to keep searching towards the right. So मैं बोलूँगा आप क्या करो, सिर्फ एक काम. अगर element mid index पे अगर k मिल भी जाए, towards the right, keep on searching. You say start equal to mid +1. That's it. This is the only change we are gonna have. So if you want that for element 3, what is the last occurrence? It should be at index 3 only, correct? Let me try running. You should be getting the answer now. So yeah, I think it's coming good, right? At index 3, the last occurrence of 3 is coming. So this is how for the last occurrence, a minor change can produce the last occurrence. Got the point? How to go for binary search, how to calculate the first occurrence, how to calculate the last occurrence. समझ आया आप सबको? पहले वो बोलो. समझ आ गया? अच्छा, I'm giving this. I think इतना easily कोई समझाएगा नहीं. मेरे को खुद समझने में बहुत पापड़ बेलने पड़े थे अपने टाइम पे. समझ आ गया? अच्छा, now last point. If you wish to calculate how many occurrences of three, let's say, are there inside your array, how can you do it utilizing binary search? Can anyone tell me? How can you calculate utilizing binary search? How many occurrences of 3 are there? No, not at all. Count wherever is the last occurrence. Last occurrence index. Last occurrence. First occurrence index. Both are binary search. Both are being implemented utilizing binary search. So I can say log n searches for the last occurrence, log n searches for the first occurrence. Am I correct? Subtract both. Last occurrence. How many occurrences are there? Can I say? How to find the number of occurrences? Last occurrence index minus first occurrence index plus 1. This will give you how many occurrences of required element k is there. Okay, just a simple formula. Log n searches for calculating the last occurrence, log n searches for the first occurrence. Overall, how many searches, how many operations we did? 2 log n. So in big O of log n, effectively, I have calculated the number of occurrences inside the sorted array. Got my point? Last occurrence की index निकालो, first occurrence की index निकालो, last occurrence minus first occurrence plus 1. ठीक है? Last occurrence से first occurrence तक जितनी भी elements है उसका count मुझे चाहिए. That's it. Last occurrence से first occurrence के बीच ही रहेगा ना 3 required element के. तो कितने elements है? Equal to that of last occurrence minus first occurrence plus 1. Overall आपने log n times में number of occurrences inside the sorted array भी निकाल लिया. ठीक है? ये आप कोड खुद से करोगे. लास्ट ऑकरेंस आप काउंट निकालने वाला पार्ट खुद से करोगे. हाउ मेनी एलिमेंट्स आर देयर इनसाइड योर करंट एरे, सॉर्टेड एरे. यूटिलाइजिंग बाइनरी सर्च, व्हाट इज द काउंट ऑफ एलिमेंट्स, यू आर गोना डू इट योरसेल्फ. फर्स्ट ऑकरेंस कैसे निकालते हैं, लास्ट ऑकरेंस कैसे निकालते हैं, मैंने दोनों बता दिया. ठीक है, टेल मी एवरीथिंग इज क्लियर. प्लीज टेल मी दैट क्लियर टू ऑल ऑफ यू. हाउ डज इट हैपेंस, बोलो. And always keep into the mind, binary search works in sorted arrays only. Okay, let it be reverse sorted, let it be ascending order sorted. Inside your sorted arrays only your binary search can work. कोई doubt है? Basics of binary search we have started today. कोई doubt है किसी को? Next day I am gonna start off, take the problems of sorted rotated array. Sorted rotated array. ठीक है, अब देखो टॉपिक्स इंटरेस्टिंग होने वाले हैं. Sorted rotated array. I'm gonna take this topic. आसान, बहुत इंपॉर्टेंट है और आपको आना चाहिए. इंटरव्यू स्पेसिफिक, इट्स वेरी इंपॉर्टेंट. ओके, कोई डाउट है तो बोल दो. Anyone faces any doubt with binary search? How do we implement? How do we code? What is the logic that's working behind? What is the time complexity? कोई डाउट किसी को? पसंद आया बाइनरी सर्च? पहले वो बोलो. पसंद आया बाइनरी सर्च?